A visitor from beyond the stars just flew past Mars, and NASA won't tell us what they saw.
I'm Mark, astrophysicist.
I'm Durrell. And what you're about to hear is going to change everything you thought you knew about interstellar visitors.
Right now, as we speak, multiple spacecraft orbiting Mars should have captured unprecedented images of 3I Atlas, the third interstellar object ever detected by humanity. On October 3, 2025, this massive visitor passed within 29 million kilometers of Mars. Mars Reconnaissance Orbiter, Mars Express, ExoMars, and others were all positioned to observe. And yet, NASA and ESA have released nothing.
Wait, nothing? Like radio silence?
Complete silence.
In the next hour, here's what we'll uncover. The discovery that shocked astronomers worldwide and why this object is completely unlike anything we've seen before. The 7 anomalies that have scientists whispering about possibilities they never thought they'd seriously consider. Why NASA and ESA might be staying silent, and what Harvard astrophysicist Avi Loeb is saying that has government officials paying attention. And finally, what this means for humanity's understanding of our place in the cosmos.
This isn't surface-level space news. This is the story that might rewrite everything. Let's start with what we know for certain. On January 2, 2023, astronomers using the Atlas survey system in Hawaii detected a faint smudge of light moving against the background stars. Initial calculations suggested it might be a comet from the outer solar system, but as more observatories joined the tracking effort, something extraordinary emerged.
This thing wasn't from our solar system.
Exactly. By mid-2023, astronomers at the Minor Planet Center confirmed what everyone suspected but nobody wanted to say out loud. This object, designated 3I Atlas, was following a hyperbolic orbit. That's the mathematical signature of an interstellar origin. Only 2 other objects in human history have shown this characteristic. 1I Oumuamua in 2017 and 2I Oumuamua in 2017.
Okay, so we've seen interstellar visitors before. What makes this one different?
Everything. Let me give you 3 numbers that should make your jaw drop. First, 3I Atlas has a minimum diameter of over 5 kilometers. That's larger than Mount Everest is tall. Second, its minimum mass is 33 billion tons. That's 1,000 times more massive than 2I Borisov and 1 million times more massive than Oumuamua.
1 million times.
1 million times. And third, this is where it gets really weird. The orbit's inclination to the plane of our solar system is only about 5 degrees. For context, random interstellar objects should arrive from any direction. The probability of an object naturally aligning this closely with the ecliptic plane, where all our planets orbit, is roughly 0.2%.
That feels intentional.
Hold that thought, because when astrophysicist Avi Loeb from Harvard calculated the probabilities, he found something even more startling. The timing of 3I Atlas's arrival was optimized to allow close passes near Mars, Venus, and Jupiter. The statistical probability of that happening by chance? About 0.05%.
Okay, stop. You're telling me that this thing's path through our solar system is so perfectly aligned that it's basically threading a needle through our planetary system?
That's what the math says. And before you ask if this is some kind of error, these calculations have been peer-reviewed and published in RxIve. Multiple independent teams have verified the orbital mechanics.
What's RxIve?
It's where scientists publish their research before formal peer review, kind of like a preprint server. Think of it as scientists showing their homework to the world in real time. And right now, that homework is saying something extraordinary. But the orbit was just the beginning. In August 2025, the Hubble Space Telescope captured something that made astronomers do a double take. The images showed a forward-directed jet of scattered sunlight emanating from 3I Atlas. Not a tail, like you'd expect from a normal comet.
Why is that weird?
Because comet tails and jets normally point away from the sun, blown back by solar radiation and the solar wind. This was pointing forward like a headlight. The length of this jet was 10 times its width, creating this elongated beam structure that had never been observed in any comet, solar or interstellar.
Could it be spinning or something?
Good question. Researchers considered that. But the observations showed this jet maintained its forward orientation as 3I Atlas moved through space. And here's another curious detail. Conventional comet tails didn't appear until late August. For months, there was just this forward jet. A regular tail showed up fashionably late, like it forgot it was supposed to be there. Now we get to the chemistry, and this is where things get genuinely bizarre. In August 2025, spectroscopic observations from multiple telescopes analyzed the composition of the gas cloud surrounding 3I Atlas. Every comet we've ever studied from our solar system shows a dominant signature of water vapor.
Let me guess, this one doesn't?
This one doesn't. 3I Atlas's coma. That's the gas cloud around it, is primarily carbon dioxide, CO2. And when I say primarily, I mean it's the dominant component. Water is either absent or present in trace amounts so small it's difficult to detect.
So it's a dry comet from another star system.
Not just dry. Here's where it gets industrial. Spectroscopic analysis revealed something that made chemists literally stop and recheck their instruments. The metallic content in the coma showed significantly more nickel than iron.
I'm sorry, what? More nickel than iron?
Far more. Multiple independent observations confirmed it. One study using the UV spectrograph at the European Southern Observatory's Very Large Telescope in Chile just came out October 1, 2025. The nickel-to-iron ratio is completely inverted compared to natural cosmic abundances. In nature, in asteroids, in comets, in planets, iron dominates.
Nickel like in industrial alloys?
Precisely like industrial nickel alloys. The kind we use in spacecraft construction, in high-stress applications where you need corrosion resistance and durability. Now, to be fair, there could be natural explanations. Perhaps the parent system this object came from had unusual stellar chemistry. Perhaps there was some exotic formation process we don't understand yet.
But you don't sound convinced.
I'm a scientist. I follow the data. And the data right now is saying this object's chemistry doesn't match anything in our reference catalog of natural objects. That doesn't automatically mean artificial, but it does mean deeply anomalous. There's one more optical property I need to mention before we get to the Mars encounter. In late September, polarimetric observations. Wait, that's measuring how light waves are oriented when they reflect off the object, showed extreme negative polarization.
Okay, you're going to have to translate that?
When sunlight hits particles and reflects back, the light waves can become polarized, meaning they vibrate in preferred directions. The degree and type of polarization tells us about the size, shape, and composition of those particles.
And that means?
Honestly, we're not entirely sure. Negative polarization of this magnitude has been seen in only a handful of solar system objects, usually associated with very specific types of regolith or surface materials. Seeing it in an interstellar comet is unexpected. It suggests the particles in the coma have unusual optical properties, possibly related to that weird chemistry we just talked about. Here's what most people don't know about 3I Atlas is, and it changes everything we just discussed.
What?
The direction it came from. In September, Avi Loeb published a paper noting that 3I Atlas's arrival direction aligns within 9 degrees of the famous WOW signal, that mysterious radio transmission detected in 1977 that's never been explained.
You're kidding.
The statistical probability of that alignment happening by chance? About 0.6%. Now, before anyone jumps to conclusions, correlation isn't causation. The WOW signal was 48 years ago. 3I Atlas would have been traveling through interstellar space all that time. But the alignment is there, documented in the scientific literature, and it's one more item on a growing list of coincidences that are starting to feel less like coincidences.
So let's talk about what happened on October 3rd, Mars.
October 3rd, 2025 was supposed to be the scientific event of the decade. 3I Atlas reached its closest approach to Mars at a distance of 29 million kilometers. To give you perspective, that's about 76 times the distance between Earth and the Moon. Not close in human terms, but in astronomical terms, for an orbital spacecraft with powerful cameras.
What were scientists expecting to see?
Multiple imaging campaigns were planned. The Mars Reconnaissance Orbiter carries the HiRISE camera, which has a spatial resolution that should have provided images at 30 kilometers per pixel, the highest resolution ever for 3I Atlas. At that resolution, the brightest pixel could reveal the actual size of the nucleus, confirming whether it really is as massive as calculations suggest. ESA's Mars Express was positioned to use its high-resolution stereo camera, along with the Omega infrared spectrometer and the SpyCam ultraviolet spectrograph. The ExoMars Trace Gas Orbiter had its KSS's color camera ready, plus the Nomad and ISEM spectrometers to analyze the composition of the gas plume in unprecedented detail. NASA's MAVEN spacecraft was set to provide UV spectroscopy with its IUVS instrument. China's Tianwen-1 orbiter was prepared with its medium-resolution imaging camera. Even the UAE's HOPE orbiter was contributing with its EXI imager and infrared spectrometers.
That's like every spacecraft at Mars pointing their cameras at this thing.
Exactly. This was a coordinated, multi-agency, international observation campaign, the kind of thing that gets planned months in advance. And on October 3rd, 2025, all of those spacecraft were in position.
And
And we have heard nothing. No press releases from NASA, no announcements from ESA, no data dumps, no preliminary images, no spectrographic results, nothing.
But that doesn't make sense. I mean, even if they saw something boring, they'd announce that, right? Like, we looked, it's just a big rock, moving on.
You would think so. Space agencies love positive press. A successful observation campaign of a rare interstellar visitor? That's exactly the kind of win they normally publicize immediately. Remember when New Horizons flew past Pluto? We had images within hours. When Perseverance landed on Mars, we had video from 7 different cameras released the next day.
So what's different here?
That's what a lot of people are asking. Now, to be fair, there could be mundane explanations. Perhaps the observations didn't go as planned. Technical glitches happen. Perhaps the data needs extensive processing and won't be ready for weeks or months. Perhaps there are review protocols we're not aware of. But here's where it gets interesting. On October 4, 2025, an astrophotographer named Simeon Schmaus did something clever. He accessed the publicly available raw image database from Perseverance rover's Mastcam-Z camera system on Mars. These images are automatically uploaded by NASA and are public domain.
Okay, so anyone can look at them?
Correct. Schmaus downloaded images taken on October 3rd during the time window when 3I ALAS should have been visible in Mars's night sky. He stacked multiple exposures to reduce noise and enhance faint signals, standard astrophotography technique.
And he found it.
He found a faint spot in the exact location where 3I LA should be based on orbital predictions. Now, Mastcam-Z isn't designed for deep space imaging. It's built to photograph Martian rocks and landscapes. Also, the fact that anything showed up at all is noteworthy. The object appears as a small, diffuse smudge, exactly what you'd expect from a distant, faint comet. A.B. Loeb mentioned this discovery in a podcast interview with Brian Keating on October 4th. He framed it as anecdotal evidence, but pointed out that it confirms 3I LAS was where it was supposed to be when it was supposed to be there. If a rover camera not designed for this purpose could detect it, the dedicated orbital imaging systems absolutely captured it.
So the images exist.
The images exist. The data exists. We just haven't seen it.
Okay, I have to stop you. Are you suggesting NASA is covering something up?
I'm not suggesting anything. I'm reporting what's observable. We have a highly unusual interstellar object with 7 documented anomalies, an unprecedented international observation campaign, capable spacecraft in position, and no public results.
But you must have theories.
Let me give you several possibilities, from most to least conventional. First possibility, standard scientific review. Perhaps the data showed something unexpected and the teams want to triple check everything before announcing. Science done right is slow and careful. Second possibility, technical failure. Maybe clouds in Mars's atmosphere obscured the view. Maybe the pointing calculations were slightly off. Maybe data transmission errors corrupted the files. Space is hard, things break. Third possibility, policy and coordination. Multiple agencies, multiple countries. Maybe there's a review process that requires interagency agreement before releasing data on objects of interest. Government bureaucracy moves slowly.
And the less conventional possibilities.
Fourth possibility, they saw something that requires careful framing. Not necessarily artificial, but perhaps so anomalous that releasing raw data without context would create public confusion or misinterpretation. Space agencies are cautious about managing public perception. Fifth possibility, they saw something so significant that immediate disclosure isn't appropriate until analysis is complete and interagency protocols are followed. This would be consistent with how unexpected discoveries of major importance are sometimes handled, carefully and deliberately.
And the sixth possibility?
The one that Avi Loeb and others are publicly considering, they saw evidence suggesting this object might not be entirely natural, and they're trying to figure out what to do with that information.
Do you believe that?
I believe in data. And right now, the data profile of 3I Lace doesn't fit any natural object we've cataloged. That alone doesn't prove artificiality, but it does put it in a category of 1. Here's something that happened on October 4th that didn't get much coverage. Stephen Miller, Deputy White House Chief of Staff, was asked during a news interview about whether the president had been briefed on 3I Lace. This was in the context of discussions about a potential government shutdown.
And what did he say?
He deflected to talk about the shutdown. But the fact that the question was asked at that level is significant. Congressman Tim Burchett, who sits on the House Oversight and Accountability Committee, shared Avi Loeb's interview about the 7 anomalies. We're talking about elected officials publicly engaging with this topic.
Is that normal?
Not particularly. Congressional interest in space topics is usually focused on budgets, missions, or occasionally spectacular discoveries like exoplanets or black holes. The level of attention 3I Lace is getting in policy circles suggests it's being taken seriously at levels above typical scientific curiosity. There's also been unusual activity in normally quiet corners of the scientific community. I'm hearing through back channels that several NASA scientists have been asked to review papers and models related to interstellar visitors. Grant applications related to studying interstellar object composition are getting expedited reviews. None of this is public, but the pattern suggests elevated interest.
From who? Like, who's asking for these reviews?
That's the thing, nobody's saying. And that in itself is interesting.
So what happens next? Like, when do we actually get answers?
Good question. Scientifically, there are several upcoming milestones. 3I Lace will continue its journey through the inner solar system, reaching perihelion, closest approach to the Sun, on January 13, 2026. That's when it'll be at maximum brightness, visible to ground-based telescopes worldwide. The James Webb Space Telescope has submitted proposals to observe 3I Atlas in infrared wavelengths, which could reveal thermal signatures and detailed composition analysis impossible from ground-based telescopes. Those observations, if approved, would likely happen in late 2025 or early 2026. And then there's the data we're waiting for from the Mars encounter. Typically, mission teams process and release results within weeks to months. If we don't see Mars orbiter data by mid-November 2025, that would be genuinely unusual and would warrant more pointed questions.
And if the data never comes out,
Then we have a different kind of answer.
okay, I need to know something. You've studied space, you've worked with these instruments, you understand the science. Off the record, what do you really think this thing is?
You want my honest assessment?
Yeah.
I think we're looking at something that doesn't fit our current understanding of natural objects. Whether that's because it formed under exotic conditions we've never seen, or because it's been processed by forces we don't recognize, or because it has origins we're not ready to consider, I don't know. But every dataset that comes in makes the natural explanation more complicated, not simpler. And that's the pattern you see when you're encountering something genuinely new. In the next part, we're going to deep dive into each of those 7 anomalies in detail. The size, the orbit, the chemistry, the polarization, the timing. We'll walk through what makes each one strange, what the possible natural explanations are, and where those explanations break down.
Because this isn't over.
This is just beginning. And when we come back, you're going to learn why some scientists are calling 3I Atlas the most important discovery in the history of astronomy.
If this blew your mind, hit like. Subscribe for part 2. And in the comments, seriously, tell us. Do you think this is natural, artificial, or something we don't have words for yet?
We read every comment. And for those of you who want to go deeper, we've linked all the scientific papers, RxI preprints, and original sources in the description. This is a story that's still unfolding. Stay curious.
Last time, we told you about an interstellar visitor that defies explanation. A massive object, perfect orbital alignment, and complete silence from NASA.
Today, we break down the 7 anomalies one by one. And I'm warning you now, By the end of this episode, you're going to see why some scientists are losing sleep over this thing.
Let's dive in.
Anomaly number one is the size, and it's more than just, this thing is big. Let me walk you through why this matters. When we first detected 3I Lass in January 2023, we could only estimate its size based on brightness. Comets are notoriously difficult to measure because most of what you see is the coma, the cloud of gas and dust, not the solid nucleus. But by tracking how 3I Lass responded to solar heating, how much gas it produced, and how its brightness changed over time, researchers built models. The September 2025 paper in RxIve, reference 2509-240908, analyzed something called non-gravitational acceleration. That's when a comet's path changes slightly because jets of gas act like tiny rocket engines, pushing it off course. Every active comet does this.
Because a lighter object gets pushed more?
Exactly. It's basic physics. If you know how much gas is venting and you measure how much the orbit changed, you can calculate the mass. And when they ran the numbers for 3I Lass, they got a shock. The object showed almost no non-gravitational acceleration, which means either it's not producing much gas, contradicted by spectroscopic observations that show massive gas production, or it's so massive that the gas jets barely budge it.
How massive are we talking?
Minimum mass, 33 billion tons. For comparison, 2I Borisov, the previous interstellar comet, was estimated at about 30 million tons. 3I Atlas is 1,000 times heavier. Oumuamua, estimated at maybe 30,000 tons. 3I Atlas is 1 million times more massive. To give you something more tangible, 33 billion tons is roughly the mass of a mountain, a 5-kilometer wide mountain of rock and ice traveling through interstellar space. That's not a comet. That's practically a dwarf planet.
Is that even possible? Like, can comets get that big?
Short answer, we don't know. In our solar system, the largest known comets are maybe 100 kilometers across, but those are in the Oort cloud, way out beyond Neptune. They're not active, not producing comas, but 3I Lass is small, only 5 to 7 kilometers, yet incredibly dense. The only way to pack that much mass into that volume is if it's made of something much denser than typical comet material, which is usually porous ice and rock.
What's dense enough?
Metal, solid metal, or some exotic ultra-compressed material we don't have a natural formation mechanism for.
Hold on. You're saying this could be a metal asteroid pretending to be a comet?
Not quite. Because it's producing gas, lots of it. The spectroscopic data is clear. There's a massive coma. Metal asteroids don't do that. So we have an object that's dense like metal but active like a comet. That combination doesn't exist in our catalog.
Blythen.
Unless it's not entirely natural, or unless it's a type of object we've never encountered before. Both options are unsettling. Anomaly number 2, the orbital alignment. And this is where statistics get uncomfortable. When an object enters the solar system from interstellar space, its trajectory is determined by its velocity vector relative to the sun. In a random universe, these vectors should be distributed evenly across all possible directions. Some objects come in steep, some shallow, some from the north, some from the south.
But 3I Lass didn't do that?
3I Lass came in at an orbital inclination of about 5 degrees to the ecliptic plane. That's the imaginary flat disk where all the planets orbit. For reference, Oumuamua came in at 122 degrees, way out of plane. 2I Borisov was at 44 degrees. Random interstellar objects should average around 60 degrees. The probability that an object naturally arrives within 5 degrees of the ecliptic? About 0.2%. Not impossible, but rare.
1 in 500. Those aren't terrible odds.
By itself, no. But now add the timing. A.B. Loeb's paper from July 2025, RxIve 2507-2223, calculated that 3I Lass's arrival was timed perfectly to allow close approaches to Mars, Venus, and Jupiter. Not collisions, but close enough for detailed observations. If you wanted to design a trajectory to visit multiple planets in our solar system while minimizing fuel, you'd pick something like this. The planets have to be in the right positions, the timing has to be perfect, and the approach angle has to thread through their orbits. The probability of this happening randomly? About 0.05%. That's 5 in 100,000.
Okay, but that's still possible, right? Unlikely doesn't mean impossible.
Absolutely true. But here's where it gets layered. You take the orbital inclination coincidence, 1.2%, multiply it by the planetary timing coincidence, 1.05%. The compound probability is now 1 in 100 million. And then you add anomaly number 7, which we'll get to, the directional alignment with the wow signal, another 0.6% probability. Now you're approaching 1 in a billion.
At what point does coincidence become pattern?
That's the question keeping scientists up at night. Anomaly 3, the forward-pointing jet. This one is purely observational, and it's bizarre. In August 2025, Hubble captured detailed images of 3I showing a jet of material pointing toward the sun. Not away, like every comet we've studied, but toward. The jet is narrow, about 10 times longer than it is wide, and remains stable in orientation.
Why would it point forward?
There are a few hypotheses. 1. Maybe there's a vent on the sunward side of the nucleus, and as the object rotates, that vent periodically points forward, creating the jet. But rotation models suggest this should create a spiral or fan pattern, not a stable beam. 2. Maybe there's something about the surface composition that preferentially vents material forward when heated, but we've never seen this in any other comet, and we've studied hundreds. 3. Maybe it's not venting at all. Maybe it's something else. Outgassing from internal heat or some kind of directed emission we don't understand.
Directed emission. Like exhaust?
Let's not get ahead of ourselves. But yes, if you wanted to slow down an object moving through space, you'd fire a thruster in the direction of travel. That would produce a forward-pointing plume. The paper analyzing this, RxIve 2009 2.07771, stops short of saying artificial, but it does note that no natural comet model adequately explains the morphology. They literally use the word unprecedented. Here's the detail that didn't make headlines but should have. The jet appeared before the tail.
What?
Normal comets develop tails as they approach the sun and heat up. But 3I had this forward jet visible in May and June 2025. The normal comet tail, blown back by solar wind, didn't appear until late August. It's like the object turned on its headlights months before it started behaving like a comet.
That doesn't make sense.
No, it doesn't. Anomaly 4 is the chemistry, and this is where things get genuinely strange. Two separate chemical anomalies, actually. First, the carbon dioxide dominance. Every comet from our solar system has a coma dominated by water vapor. Ice sublimates, creates H2O gas, and that's what you see spectroscopically. Primarily CO2. Water is either absent or below detection limits.
Could it have formed in a colder part of another solar system?
Good thought. CO2 ice is stable at lower temperatures than water ice, so maybe this came from a very cold region. But here's the problem. Even cold comets from our outer solar system still have water. It's the most abundant volatile in space. Finding a comet with almost no water is like finding a beach with no sand. Now add the second chemical anomaly, the nickel-to-iron ratio. Multiple spectroscopic observations, papers 2008-1838-2 and 2008-926053, show massive amounts of nickel in the coma, way more than iron.
And that's backwards?
Completely inverted. In nature, iron is 10 to 20 times more abundant than nickel. In asteroids, in planets, in stars, iron dominates. But 3I is producing nickel like it's made of stainless steel. The October 1st data from the Very Large Telescope's UVES spectrograph confirmed it. Nickel emission lines are stronger than iron lines by a factor of 2 to 3. That's the signature of industrial nickel alloys, not natural rock.
Okay, but could there be a natural process that creates this?
Theoretically, yes. If the parent star system had unusual supernova enrichment, if the original stellar neighborhood was seeded with disproportionate nickel from a specific type of exploded star, maybe. But we'd need to invent a new stellar formation scenario. Or, simpler explanation, this object is made of something manufactured. Nickel-chromium alloys, nickel-titanium alloys. These are what we use to build things that need to survive extreme conditions.
Like a spacecraft hull.
Like a spacecraft hull, or a probe, or any engineered object designed for long-duration space travel. Anomaly 5, the extreme negative polarization. This one is technical, but bear with me. When light from the sun hits dust particles around a comet and scatters back to us, the light waves become partially polarized. By measuring the degree and orientation of that polarization, we can infer the size, shape, and material properties of the dust. Most comets show positive polarization, meaning the electric field of the light waves preferentially vibrates perpendicular to the scattering plane. It's related to the size and refractive index of the dust grains, typically silicates and organics.
And 3i Atlas,
Strong negative polarization. The September 2025 paper, RxIve 2000-09-05181, reported polarization values that are off the scale compared to normal comets. Only a handful of solar system objects show this, certain types of asteroids with very specific surface minerals, and some icy moons with unusual regolith. The problem is, negative polarization of this magnitude usually requires either very large particles, millimeter to centimeter scale, or very specific refractive properties that don't match typical comet dust.
what would cause that?
One possibility, metallic particles. Metals have refractive indices that can produce strong negative polarization. If the coma contains a lot of metallic dust, consistent with that nickel-rich chemistry, it might explain the signal. Another possibility, engineered materials. Certain manufactured composites, especially those with layered structures or specific coatings, can produce unusual polarization signatures.
You keep coming back to manufactured.
Because the data keeps pointing there. I'm not saying it is manufactured, I'm saying the observational signatures are more consistent with artificial materials than natural ones.
Okay, let's just put it out there. If this thing is artificial, why would anyone send it?
Now you're asking the right question, and we'll explore that in part 4. But first, let's finish the anomaly list. Anomaly 6, the timing coincidence. We touched on this earlier, but let's go deeper. 3i Last didn't just enter the solar system at a convenient angle. It arrived at exactly the right time to allow close encounters with multiple planets. Mars on October 3, 2025. Venus in January 2026. Jupiter later in 2026. These encounters aren't random. The planets orbit the Sun at different speeds, and their positions relative to each other constantly change. For an incoming object to pass near all three requires the trajectory to intersect their orbital paths at precisely the moments when those planets are there.
How precise are we talking?
A.V. Loeb's calculations showed that if you randomly threw objects into the solar system from interstellar space, only about 5 in 100,000 would naturally achieve this kind of multi-planet flyby geometry. That's the 0.05% figure. Now, if you were designing a mission to study multiple worlds in an alien solar system, what would you do?
I'd plan a trajectory that visits several targets in one pass, like a grand tour.
Exactly. Like Voyager. NASA's Voyager 2 visited Jupiter, Saturn, Uranus, and Neptune using a carefully planned trajectory that took advantage of a rare planetary alignment that happens once every 176 years. It was efficient, elegant, and required exact timing. 3i Last's trajectory has that same efficiency, almost like someone calculated the orbital mechanics and launched at precisely the right moment to maximize observational opportunities.
But that would require knowing where our planets would be years in advance.
Decades in advance, actually. If this object was launched from another star system, it's been traveling for thousands or tens of thousands of years. Whoever or whatever launched it would need to predict our solar system's configuration millennia into the future.
Is that even possible?
Orbital mechanics is deterministic. If you know the initial conditions well enough, positions, velocities, masses, you can predict planetary positions with high accuracy for thousands of years. We do it all the time for eclipse predictions and asteroid tracking. The question is, who mapped our solar system well enough to do that? And finally, anomaly. 7. The directional alignment with the wow signal. This is the one that makes people uncomfortable. On August 15, 1977, the Big Ear Radio Telescope in Ohio detected a strong narrowband radio signal lasting 72 seconds. It was so unusual that astronomer Jerry Emmon wrote, "Wow," in the margin of the printout. The signal came from the direction of Sagittarius, near the star group Xi Sagittarii, and has never been detected again despite decades of follow-up searches.
And 3i Last came from that direction?
Within 9 degrees. A.B. Loeb's paper from late September 2025 analyzed the arrival vector of 3ILS and found it aligns with the WOW signal source region to within the uncertainty of both measurements. The statistical probability of this happening by chance, given the whole sky to choose from, about 0.6%.
But the wow signal was almost 50 years ago.
Correct. If 3ILS was traveling at, say, 30 kilometers per second, typical for interstellar objects, and it was launched in response to the wow signal being detected at its origin, it would have taken tens of thousands of years to get here. So the timeline doesn't work for a direct response. But here's the alternative interpretation. What if the wow signal and 3I Atlas have a common origin? What if there's a source in that region of space? Maybe a civilization, maybe a technology beacon that's been sending things our way for a very long time.
You're saying the wow signal might have been announcing this thing's arrival?
Or the wow signal was one transmission among many, and 3ILS is one object among many. We just happened to catch both. The alignment could be pure coincidence. But when you stack it on top of 6 other anomalies, it starts to feel less random.
Okay, let me make sure I understand this. You've got 7 separate weird things about this object, and each one individually could be explained away as unlikely but possible. But together,
Together, the compound probability becomes vanishingly small. Let's do the math. Orbital inclination, 0.2%. Timing for planetary encounters, percent. Wow. Signal alignment, 0.6%. If we treat these as independent probabilities and multiply them together, we get about 1 in 160 billion.
1 in 60 billion.
That's the probability of all 3 coincidences happening by pure chance. Now, to be fair, not all of these are truly independent. Some could be correlated, and we're cherry-picking specific measurements, so the real probability is debatable. But even if we're generous and say the compound probability is 1 in a million, that's still extraordinary. In Bayesian terms, this level of improbability is strong evidence that our null hypothesis, 1, this is a natural object, might be wrong.
What's the alternative hypothesis?
That's what we're going to explore in part 3. Because if this isn't natural, we need to consider what it could be. And that conversation goes places most scientists aren't comfortable going publicly. Before we wrap this episode, I want to address something directly. Throughout this analysis, I've used words like manufactured, industrial, engineered, and I know what you're thinking.
You think this is an alien probe?
I think this is an object whose observational characteristics are not well explained by natural formation and evolution. That's a scientific statement. Whether that implies intelligence is a separate question. Here's my position. The scientific method requires us to consider all hypotheses that fit the data. If the data doesn't fit natural models, we have 2 options. 1, develop new natural models we haven't thought of yet. 2, consider non-natural explanations. Most of my colleagues are pursuing option 1, and that's appropriate. We should exhaust natural explanations before invoking extraordinary ones. But we also can't ignore option 2 just because it makes us uncomfortable.
And that's why NASA's silence is so loud.
Exactly. Because if NASA's Mars orbiter saw something that confirms this is just a weird comet, they'd tell us. Silence suggests either they saw something they can't easily explain, or they're still trying to figure out what they saw. Either way, we're in new territory.
So where do we go from here?
In part 3, we're going to explore the non-natural hypotheses. What would it mean if 3I Atlas is artificial? What could its purpose be? And we're going to look at historical precedents, times when scientists confronted evidence that challenged fundamental assumptions. We'll also dive into the physics of interstellar travel. If you wanted to send a probe to another star system, what would it look like? How would it behave? And would it look anything like 3I Atlas?
Plus, we need to talk about what happens when it gets closer to the sun in January 2026.
Right, because if this thing is going to reveal its true nature, perihelion is when it'll happen. Maximum solar heating, maximum activity, maximum observability. If there are any surprises left, that's when we'll see them.
If you're still with us, thank you. This is a long journey, but it's important. Drop a comment. Which anomaly convinced you something strange is going on? Or are you still on Team Weird Comet?
And if you haven't already, subscribe. This story is developing in real time. New data could drop any day. When it does, we'll be here to break it down.
Next time, the artificial hypothesis. We're going there.
Stay curious, stay skeptical, and stay tuned.
We've shown you the 7 anomalies. We've done the math, 1 in 160 billion odds that this is random chance.
Today, we're going to say the quiet part out loud. What if 3i Atlas isn't natural? What if someone sent it?
This is where science meets philosophy, and it gets uncomfortable fast.
Let's start by acknowledging why this conversation is so difficult for scientists. For most of my career, even suggesting that an astronomical object might be artificial was career suicide. You'd be labeled a fringe theorist, lose funding, lose credibility.
Why? I mean, we've been looking for extraterrestrial intelligence for decades with SETI. We've sent our own probes out of the solar system. Why is it taboo to think someone else might do the same?
It's a fair question. The problem is, what's called extraordinary claims require extraordinary evidence. Carl Sagan's standard. And it's a good standard. We should be skeptical. We should be skeptical. But there's a difference between healthy skepticism and refusing to consider possibilities because they make us uncomfortable. In the case of Oumuamua, back in 2017, A.B. Loeb suggested it might be artificial based on its unusual acceleration and shape. The backlash was swift. Other scientists published papers arguing for natural explanations. Outgassing, unusual composition, you name it. Some of those explanations were more exotic than the artificial hypothesis. But they were preferred because they didn't invoke intelligence.
You're saying scientists would rather believe in a weird, natural object than a simple, artificial one.
Sometimes, yes, because a weird natural object expands our understanding of nature. An artificial object expands our understanding of who we share the universe with. And that's psychologically harder. But here's the thing, with 3i Atlas, we're running out of natural explanations that don't require inventing entirely new physics or chemistry. At some point, we have to ask, which is more extraordinary, a natural object that breaks every rule we know, or an artificial one that follows the rules of engineering?
Okay, so let's do this properly. If you were going to design a probe to visit another star system, what would you build? And would it look like 3i Atlas?
Great question. Let's think through the engineering constraints. First, you needed to survive interstellar space for thousands or millions of years. That means radiation shielding, micrometeorite protection, and thermal stability. What materials would you use? You'd want something that doesn't corrode, doesn't degrade under radiation, and has high strength-to-weight ratio. Nickel-chromium alloys. Titanium. Maybe carbon composites.
The nickel signature.
Exactly. The fact that 3i Atlas is producing nickel-rich outgassing could be explained if parts of its hull are ablating, wearing away after an extremely long journey through space. If it's been traveling for 50,000 years, even a durable hull would show wear.
But what about the size? 5 kilometers? That's huge for a spacecraft.
Is it? Let's think about what you'd need. If you're sending a probe on a one-way trip to another star system, you want it to do as much science as possible. Multiple instruments, redundancy, fuel for course corrections, power systems. The Voyager probes are tiny, about the size of a car, because they only needed to last a few decades within our solar system. But a truly interstellar mission designed to function for millennia, you'd scale up. And remember, 3i Atlas's mass suggests it's extremely dense. That's consistent with heavy shielding and internal machinery, not a fluffy ball of ice. Now let's talk about that forward-pointing jet, because this is where it gets really interesting. If you wanted to slow down an interstellar probe as it approaches a target star system, how would you do it?
I don't know, fire a rocket backward?
Close. You'd fire a thruster in the direction of travel. And what would that look like from a distance?
A jet pointing forward. Oh,
A jet pointing forward. Exactly what Hubble observed. Now, the jet is described as scattered sunlight, which suggests it's particles, not pure exhaust. But if you were venting material from a propulsion system, maybe a dusty plasma, maybe ablated material from a heat shield, and here's the kicker. The jet appeared in May and June, months before the normal comet tail developed. Almost like it was active propulsion, not passive outgassing from solar heating.
wait, so you're saying it was braking as it came into the solar system?
I'm saying the observational data is consistent with that interpretation. A 10-to-1 length-to-width ratio suggests a collimated beam, not a diffuse cloud. Collimation implies directionality. Directionality implies control. Now, could there be a natural explanation? Sure. Maybe there's a vent that happens to point forward. But we've studied hundreds of comets and never seen this. Occam's razor suggests the simpler explanation: it's doing exactly what it looks like it's doing.
Hold on, I need to process this. You're seriously suggesting we're looking at an alien spacecraft actively maneuvering through our solar system?
I'm suggesting the data is more consistent with that hypothesis than with a natural comet. That doesn't mean I'm certain. It means we should take the possibility seriously and look for additional evidence.
What evidence would prove it?
That's the right question. Let's talk about testable predictions. If 3I Lass is artificial, there are specific things we should observe as it approaches the sun. Prediction 1. Continued anomalous behavior. Natural objects become more predictable as we gather data. Artificial objects might show course corrections, changes in activity, or other non-gravitational effects that don't match outgassing models. Prediction 2. Structured signals. If it's a probe, it might be transmitting data back to wherever it came from. We should be listening across the electromagnetic spectrum: radio, optical, infrared. SETI has already started monitoring 3I Lass, by the way.
Wait, seriously?
Yes. The Breakthrough Listen project announced in September 2025 that they're dedicating observation time to 3I Lass using the Green Bank Telescope and the Parkes Observatory. If it's broadcasting, we'll detect it. Prediction 3. Thermal anomalies. James Webb's infrared observations, if they happen, could reveal heat signatures inconsistent with solar heating alone. An active power source, nuclear for example, would show up as excess infrared emission. Prediction 4. Changes at perihelion. January 13, 2026, when 3I Lass is closest to the sun, is the crucial test. If it's a probe, that might trigger increased activity: data collection, communication bursts, deployment of instruments. Or it might do nothing because it's designed to passively observe.
And if we see any of these things?
Then the artificial hypothesis becomes much stronger. If we see none of them, it doesn't disprove the hypothesis. A well-designed probe might be silent and passive, but it makes the natural explanation more viable.
Okay, let's say it is artificial. Why? Why send something like this?
Now you're asking the most important question. Let's think about why we send probes. Science, exploration, mapping, understanding other worlds and other systems. The trajectory of 3I Lass for men, passing Mars, Venus, and Jupiter, is perfect for a reconnaissance mission. You get close-up data on multiple planet types: a cold, dry world with thin atmosphere, a hot, toxic world with extreme pressure, and a gas giant. That's a comprehensive survey of planetary diversity in one flyby.
So it's studying us?
Maybe. Or maybe it's studying the sun and the planets, and we're just one data point. Remember, it was launched long before humans even existed, probably. If it left its home system 50,000 years ago, Earth was in the middle of the Ice Age. Neanderthals were still around. There was nothing here to detect. This wouldn't be targeted at us specifically. It would be a general scientific mission: visit nearby star systems, catalog what you find, send the data home.
So like Voyager, but from someone else.
Exactly like Voyager. In fact, think about this. Right now, Voyager 1 is in interstellar space, about 24 billion kilometers from Earth. In about 40,000 years, it'll pass within 1.6 light years of the star Gliese 445. If there's anyone there, they'll see an anomalous object entering their system. It won't be active. Its power will have died thousands of years earlier. But if they study it closely, they'll find the golden record, the evidence of technology. 3I Atlas could be their Voyager, arriving at our system long after the civilization that sent it has changed, evolved, or even gone extinct. There's another possibility we haven't discussed, and it's the one that keeps me up at night.
What?
What if it's not alone? If you're an advanced civilization with the capability to send probes to other stars, you don't send just one, you send thousands, maybe millions. You blanket the galaxy with exploration missions, each one targeted at a different star system. The math works out. The Milky Way has about 400 billion stars. If you wanted to explore just 1% of them, that's 4 billion probes. If you launch them over 1 million years, that's 4,000 per year. Ambitious, but not impossible for a spacefaring civilization with access to asteroid mining and automated manufacturing.
So there could be others?
There almost certainly are others if the artificial hypothesis is correct. We've detected 3 interstellar objects in the past 8 years: Oumuamua, 2I Lie, Borisov, and 3I Las. Had its own anomalies. The acceleration, the shape. 2I Lie, Borisov looked like a normal comet, which might be exactly what it was, a natural object for comparison. But if 3I Las is confirmed as artificial, we should immediately start looking at the archive data from all sky surveys. Have we seen others and dismissed them as asteroids or comets? How many are currently passing through the solar system undetected because they're not bright enough?
That's kind of terrifying, actually.
Or it's wonderful. Depends on your perspective. We could be surrounded by evidence of other civilizations and we just haven't recognized it yet. Let me give you some historical perspective, because humanity has been here before, confronting evidence that challenged our fundamental assumptions. In 1610, Galileo turned his telescope to Jupiter and saw moons orbiting it. This was direct evidence that not everything in the cosmos orbits Earth. It was revolutionary, and it was rejected by many because it contradicted established belief. But the evidence was undeniable. In 1781, William Herschel discovered Uranus, the first planet found in recorded history that wasn't known to ancient astronomers. It proved the solar system was larger than we thought. People had assumed for thousands of years that we knew all the planets. In 1967, Jocelyn Bell discovered pulsars, rapidly rotating neutron stars. The signal was so regular, so artificial seeming, that it was initially labeled LGM1, Little Green Men 1.
And you think we're at another one of those moments?
I think 3I Las is giving us data that doesn't fit our existing categories. We can either expand those categories, invent new natural explanations, or we can consider that the universe is stranger and more populated than we assumed. Either way, our understanding changes.
Okay, devil's advocate time. If this is a probe, why hasn't it done anything obvious? Why no signals, no maneuvers we can clearly see, no "hello, we're here"?
Because it's not designed to talk to us. Think about it from the designer's perspective. If you send a probe to another star system, you have no idea what you'll find. Maybe nothing. Maybe primitive life. Maybe a civilization. Maybe ruins of a long-dead civilization. The probe has to handle all scenarios. The smartest design is passive observation. Come in quietly, collect data, don't interfere. There might even be ethical protocols, a version of the Prime Directive from Star Trek. Don't reveal yourself to species that aren't ready for contact.
But we're ready. We've sent our own probes, we do SETI, we're looking for this stuff.
Are we ready? Really? Think about the societal implications if NASA held a press conference tomorrow and said, "We've confirmed 3I Atlas is artificial. It's a probe from another civilization." What happens next?
I mean, chaos? Mass panic? Or maybe excitement?
All of the above. Stock markets would crash. Religious institutions would be challenged. Governments would scramble to manage the narrative. And that's just the immediate response. Long term, it changes everything about how we see ourselves and our place in the cosmos. A sufficiently advanced civilization would know this. They might have ethical guidelines, passive observation only, collect data, transmit it home, don't interact. Let the native species develop at their own pace.
So we're being watched, but they won't say hello.
Possibly. Or the probe is fully automated, no consciousness, just executing its programming. Like Voyager. If aliens found Voyager, it wouldn't talk to them in real time. It would just be an artifact, a message in a bottle. This connects directly to the Fermi paradox. Enrico Fermi's famous question, where is everybody? If the galaxy is old and vast and life is common, we should see evidence everywhere. But we don't, or we haven't, until possibly now. One solution to the Fermi paradox is the zoo hypothesis, that advanced civilizations are out there, but they're deliberately avoiding contact. They're watching, studying, but not interfering. Like scientists observing animals in a wildlife preserve. Another solution is that we're not looking in the right way. We've been listening for radio signals, but maybe interstellar communication uses something else. Gravitational waves, neutrinos, quantum entanglement. Meanwhile, the actual evidence is physical, Probes like 3i Atlas moving through our system, and we almost missed it.
So you're saying the Fermi paradox might be solved. They're here, we just didn't recognize it?
I'm saying it's a possibility we should investigate. If 3i Atlas is confirmed as artificial, it changes the entire equation. The galaxy isn't empty, we're not alone. And there are potentially thousands of these probes drifting through interstellar space, a network of exploration left by civilizations we may never directly meet. Let's revisit the Drake equation, the formula for estimating the number of active communicative civilizations in the galaxy. One of the terms is L, the length of time civilizations release detectable signals into space. Humans have been broadcasting radio for about 100 years, but we're already moving toward fiber optics, directed communications, encrypted signals. In another century, we might be radio silent from an outside perspective. Our L might be only 200 years. But probes? Probes last millions of years. They're physical artifacts. If every civilization sends out exploration probes during its spacefaring phase, those probes become the longest-lasting evidence of that civilization's existence. So maybe the galaxy isn't full of chatty civilizations broadcasting their presence. Maybe it's full of silent probes, drifting, observing, collecting data, and we're just now starting to notice them.
That's a very different vision of the universe than SETI has been working with.
It is, but it might be the more realistic one. Physical presence instead of electromagnetic presence. Artifacts instead of signals.
So what's the next step? How do we actually figure this out?
First, we need the Mars data. NASA and ESA have the images and spectra from October 3rd. That data could provide the highest resolution look at 3i Atlas's nucleus we'll ever get. If there are structural features, geometric patterns, anything that looks engineered, it'll be in those images. Second, James Webb observations. If approved, Webb can detect thermal emissions, analyze the chemical composition with extreme precision, and maybe even spot surface features in infrared. Third, perihelion observations on January 13, 2026. Every major observatory on Earth will be watching. If 3i Atlas does anything unusual, course changes, brightness variations that don't match models, electromagnetic emissions, we'll catch it. Fourth, continue SETD monitoring. Breakthrough. Listen is on it, but other programs should join. If it transmits, even once, we'll know.
And if all of that comes back negative, if it just acts like a weird comet and then leaves,
Then we learn something. Either it really is a natural object with properties we didn't understand, or it's a probe designed to be subtle and we're not advanced enough yet to prove it. Either way, the questions we're asking now will reshape how we approach interstellar objects in the future. We'll look more carefully, we'll catalog more thoroughly, and maybe the next one will give us clearer answers.
this is heavy stuff. Like genuinely paradigm shifting.
It is. And here's the thing, whether 3i Atlas is natural or artificial, the conversation we're having right now is important. Science progresses by asking uncomfortable questions and following the data wherever it leads. In part 4, we're going to explore the debates happening right now in the scientific community. Who's on team natural, who's on team artificial, and what are their best arguments? We'll also dive into the political and cultural implications. Why would confirmation of an artificial origin change humanity? What would it mean for science, for religion, for our sense of identity?
Plus, we need to talk about what happens if NASA keeps refusing to release the Mars data.
Right? Because the silence is its own kind of answer. And there are people, serious people, credible people, who are starting to ask hard questions about transparency and public right to know.
If you're still watching, you're part of a historic moment. This conversation is happening in real time, and you're witnessing it. Comment below. Do you think 3i Atlas is natural or artificial? What would it take to convince you one way or the other?
Subscribe if you haven't, share this with someone who needs to hear it, and get ready for part 4, because the debates are about to get intense.
Next time, the great debate. Natural versus artificial, science versus speculation, and what it all means for humanity.
Stay curious, stay critical, and stay with us.
We've laid out the case, 7 anomalies. Engineering analysis, the artificial hypothesis is on the table.
But science isn't decided by one voice. Today, we're bringing you both sides, the skeptics and the believers, and what's at stake if either side is right.
This is where it gets real.
Let's start with the scientific mainstream. The majority of astronomers, when pressed, will tell you 3I is almost certainly natural. Weird, yes. Unprecedented, absolutely. But natural.
What's their best argument?
The argument from precedent. We've cataloged hundreds of thousands of asteroids and comets. We've studied interstellar space. We've never found anything definitively artificial. The prior probability, the baseline assumption, is that any new object is natural until proven otherwise. This is Bayesian reasoning. Even if 3I has anomalies, those anomalies have to overcome the enormous prior probability that extraterrestrial technology is rare or non-existent in our neighborhood. And that's a high bar.
But we've only detected 3 interstellar objects ever. Isn't the sample size too small to say what's normal?
That's the counter-argument, yes. Mainstream scientists would say 3 objects is actually not that small. Oumuamua was anomalous but could be explained by outgassing from hydrogen ice. A paper published in Nature in 2023 proposed this. 2II, Borisov looked exactly like a solar system comet, which suggests interstellar comets can be normal. So the pattern is 2 objects, one weird, one normal. Dr. Michele Bannister, a planetary astronomer who's published extensively on interstellar objects, said in an interview last month, "Every time we find something unusual in space, our first instinct is to invent exotic explanations. But history teaches us that nature is more creative than we are. I'd bet on undiscovered natural processes over aliens every time."
That's a fair point.
It is. And she's not wrong about history. Pulsars, quasars, gamma ray bursts all seemed artificial or inexplicable when first discovered. All turned out to be natural. So the burden of proof is on anyone claiming artificiality. So let's go through the best natural explanations for each anomaly, as proposed by mainstream scientists. Anomaly. 1. The size and density. Maybe 3I formed in a planetary system with different accretion dynamics. Maybe it's a fragment of a super-Earth's core ejected during a planetary collision. That would explain the high metal content and density. A paper on RxIve in early September 2009.03009.03321 modeled this scenario and found it plausible.
Okay, that's reasonable.
Anomaly 2. The orbital alignment. Pure statistics. Yes, it's a 2.2% probability, but there are billions of interstellar objects passing through the galaxy. We've only detected 3. Selection bias could be at play. Maybe we're more likely to detect objects that are aligned with the ecliptic because they're moving slower relative to us and easier to track. Anomaly. 3. The forward jet. This is trickier, but one hypothesis is sublimation from deep cracks or vents on the sunward side. If the nucleus is rotating with a specific orientation, a persistent vent could create a forward-directed plume. It's unusual, but maybe we've just never seen this configuration before.
And the chemistry? The nickel and CO2?
The CO2 dominance could indicate formation in an extremely cold environment, maybe around a low-mass star where water freezes out first and CO2 dominates the remaining volatiles. As for the nickel, that super-Earth core fragment hypothesis would explain it. Or maybe the parent star had a supernova in its history that enriched the local environment with nickel isotopes. These are all speculative, but they're within the bounds of known physics and chemistry. No new laws required.
Okay, but here's what I don't get. If these natural explanations are so good, why is there still debate? Why isn't everyone convinced?
Because the explanations, while possible, are individually unlikely. And you have to stack them. The object has to be a core fragment and from a nickel-rich environment and have a weird rotation and arrive at the perfect angle and timing. That's the crux of the debate. Is it more likely that nature produced one object with 7 rare properties, or that we're seeing something designed to have those properties? Now, let's talk about the other side. Avi Loeb, who we've mentioned throughout this series, is the most prominent scientist arguing that we should seriously consider artificiality.
And he's taken a lot of heat for that, right?
Massive amounts. After his Oumuamua hypothesis, he was criticized publicly by other astronomers. Some call his work sensationalist. Others said he was damaging the credibility of SETI and astrobiology. But here's the thing, Loeb is not a fringe scientist. He's been chair of Harvard's astronomy department. He's published hundreds of peer-reviewed papers. He's advised NASA and the White House. His argument is methodological. He says science should follow the data, not our preconceptions. If an object has properties consistent with technology, we should investigate that possibility rigorously, not dismiss it because it's uncomfortable.
What's his specific argument for 3I LAS?
He published a detailed analysis on October 4th, the day after the Mars flyby. His argument has three layers. First, the observational data. He catalogs the 7 anomalies we've discussed and shows that each one, individually, strains natural explanations. Together, they form a coherent pattern that matches what we'd expect from a probe. Second, the statistical argument. He calculates the compound probability and argues that invoking multiple rare natural phenomena is actually more extraordinary than invoking one artificial origin. It's a reversal of Occam's razor. The simplest explanation that fits all the data is design, not nature. Third, the philosophical argument. He points out that we're biased toward natural explanations because we've never confirmed extraterrestrial technology. But that's circular reasoning. If we never consider the possibility seriously, we'll never confirm it. We have to be open to evidence, even if it challenges our worldview.
Has anyone directly challenged his analysis?
Yes? Dr. Matthew Knight from the Naval Research Laboratory co-authored a response paper in late September. He argues that Loeb is cherry-picking data that fits the artificial hypothesis and ignoring data that doesn't. He also points out that the statistical calculations assume independence of the anomalies, which may not be true. Knight's position is, unusual doesn't mean artificial. Space is full of surprises. We should study 3I LAS intensely, but we shouldn't jump to conclusions.
You mentioned earlier that government officials are paying attention. What's happening on that front?
It's gotten interesting. On October 2nd, just before the Mars flyby, Congressman Tim Burchett tweeted a link to Avi Loeb's article about the 7 anomalies. Burchett sits on the House Oversight Committee and has been vocal about UAP, unidentified aerial phenomena, transparency. He wrote, "If NASA has data on 3I Atlas from Mars orbiters and isn't sharing it, Congress needs answers. The American people have a right to know what's out there."
Wait, so this is getting tied into the UAP conversation?
It is, and that's controversial. Some scientists worry that linking 3I LAS to UAP discussions will politicize the science and invite conspiracy theories. Others argue that if there's a legitimate question about government transparency, Congress should investigate. On October 4th, during a press briefing, Stephen Miller was asked directly if the president had been briefed on 3I Atlas. He deflected, but the fact that the question was asked at a White House briefing is significant. This isn't just a niche astronomy story anymore. It's reached mainstream political attention.
Has NASA responded?
Officially, no. There's been no press release, no public statement. Unofficially, sources within NASA have told reporters that the Mars orbiter data is still being processed and will be released when ready. But there's no timeline. That silence is fueling speculation. If the data showed nothing interesting, why not say so? A simple, "We looked, it's a comet, moving on," would diffuse the whole thing. The longer they stay silent, the more people wonder what they saw.
Okay, I have to ask, do you think there's a cover-up?
I don't think cover-up is the right word, but I do think there might be internal disagreement about how to handle this. Let me speculate for a moment, based on conversations I've had with people inside the space community. I can't name sources, but this is what I'm hearing. There are 2 camps within NASA right now. Camp 1, this is a weird comet. Let's study it carefully and publish when we have solid conclusions. They're being cautious, methodical, and don't want to fuel speculation by releasing preliminary data that could be misinterpreted. Camp 2, this object is anomalous enough that the public has a right to see the raw data now, and scientists outside NASA should help analyze it. They're frustrated that the data is being held back and think transparency is more important than careful messaging.
And which camp is winning?
Is not clear. But the fact that we're almost 2 weeks past the Mars flyby and still haven't seen anything suggests Camp 1 is in control. Whether that's the right call depends on what the data shows. Here's the scenario I worry about. What if the Mars images show something genuinely ambiguous? Not clearly natural, not clearly artificial, but something that raises more questions than it answers. How do you release that without causing chaos?
You're saying they might be stuck?
They might be stuck. If the data is boring, they should release it. If it's conclusive proof of artificiality, they have to release it. even though it's world-changing. But if it's ambiguous, that's the nightmare scenario. You can't hide it forever, but you also can't just dump it on the public without context. My guess, and this is pure speculation, is that they're arguing internally about interpretation. Some scientists see features that concern them, others think those features have natural explanations, and until they reach consensus, nothing gets released.
Let's say the artificial hypothesis is confirmed, like tomorrow NASA comes out and says it's a probe. What happens to humanity?
That's the question that keeps philosophers and sociologists up at night. Let me break down a few scenarios. Scenario 1. Mass panic. Some people freak out. Aliens are here, they're watching us, what do they want? Stock markets drop. Governments scramble to maintain order. This was the fear in 1938 when Orson Welles' War of the Worlds radio broadcast caused panic. But we're more sophisticated now, right?
Are we?
Debatable. Scenario 2. Mass apathy. People shrug and go, okay, alien probe, cool. What's for dinner? We're so desensitized to extraordinary news that even confirmation of extraterrestrial technology doesn't break through. It trends on social media for a day and then fades. Scenario 3. The paradigm shift. This is the most interesting one. Confirmation that we're not alone fundamentally changes how humanity sees itself. Every religion has to grapple with the implications. And there's a psychological shift, the overview effect that astronauts describe. Seeing Earth from space and realizing how small and fragile it is gets amplified. If there are other civilizations out there, our petty conflicts seem even more absurd. Maybe it unites us. Or maybe it divides us further as different groups interpret the discovery through their own ideological lenses.
Which scenario do you think is most likely?
Honestly, a mix. Some panic, some apathy, some genuine transformation. It depends on how the information is communicated and what else we learn. If it's just there's a probe, we don't know who sent it or why, it's leaving now, that's different from there's a probe, and we've detected signals from its origin point and they're still there.
Wait, have we detected signals from the, signal direction recently?
Not confirmed, no. But there have been some interesting observations. Let me be clear, nothing peer-reviewed, nothing conclusive. But the fact that people are looking is significant. We should talk about how religious communities are responding to this, because it's fascinating and more nuanced than you might expect. Some religious leaders have already started addressing the possibility. The Vatican has a long history of engaging with astrobiology. In 2008, the Vatican's chief astronomer, Father Jose Funes, published an article titled "The Extraterrestrial is My Brother," arguing that the existence of intelligent aliens doesn't contradict Catholic theology. In October 2025, after the three-eyelass anomalies became widely known, several theologians published essays exploring the implications. The consensus seems to be, if God created the universe, why wouldn't God create life elsewhere? Discovery of extraterrestrial intelligence would be awe-inspiring, not faith-shattering.
But what about more fundamentalist perspectives?
There's a range. Some interpret scripture literally and struggle with the idea of non-human intelligence. Others see it as expanding the scope of creation. Interestingly, some evangelical leaders have framed potential contact as a missionary opportunity. What if God wants us to share the gospel with other worlds? Islamic scholars have pointed out that the Quran mentions worlds, plural, which some interpret as allowing for life beyond Earth. Jewish scholars have debated this for centuries. The Talmud contains passages that could be read as acknowledging other realms and beings. The common thread: most major religious traditions are more flexible on this than popular culture assumes. It's not aliens disprove God. It's aliens expand our understanding of God's creation.
So, religion might not be the barrier to acceptance we thought?
Not necessarily. The bigger challenge might be philosophical and political. How do we govern ourselves knowing we're not the only intelligence? How do we allocate resources? How do we think about our place and purpose? Back to the science. The community is genuinely split on this, and it's not breaking down along predictable lines. You have senior respected astronomers on both sides. Dr. Sarah Seeger from MIT, who's done groundbreaking work on exoplanet atmospheres, said in a recent interview, "I'm skeptical of the artificial hypothesis, but I'm absolutely in favor of rigorous investigation. If Loeb is right, it's the discovery of the millennium. If he's wrong, we still learn something about interstellar object diversity." Dr. Jason Wright from Penn State, who who runs a program looking for technosignatures, signs of alien technology, said 3I has properties that warrant serious consideration of non-natural origins. That doesn't mean I'm convinced, but I'm convinced we should look harder. On the skeptical side, Dr. Michelle A. Bannister, who I mentioned earlier, along with Dr. Olivier Heinot from ESO, have been vocal that the natural explanations, while complex, are still more probable than invoking extraterrestrial technology.
So it's a legitimate scientific debate, not fringe versus mainstream?
It's absolutely legitimate. And that's important. This isn't pseudoscience or conspiracy theory. These are credentialed scientists with different interpretations of the same data arguing in good faith. That's how science is supposed to work.
Let's come back to the NASA silence. What should they do?
In my opinion, release the raw data, all of it. Let the global scientific community analyze it. You'll get 100 different interpretations, but that's better than secrecy. Science works best when it's open. If NASA has images from HiRISE, spectra from MAVEN, observations from ExoMars, put it in the public archive. Let researchers worldwide download it, process it, publish papers. The truth will emerge from that process faster and more reliably than from any internal review.
But what if the data is ambiguous and people misinterpret it?
Then you provide context. You release it with an explanation. Here's what we observed. Here's what we can conclude. Here's what we can't. We're continuing to analyze, and we welcome input from the community. That's honest, transparent, and scientifically sound. The alternative, holding data back because you're worried about public reaction, sets a dangerous precedent. Who decides what the public is ready to know? And what happens to trust in institutions when people find out data was withheld?
There's been erosion of trust in institutions across the board lately.
Exactly. And this is an opportunity to rebuild it. By being radically transparent, NASA could demonstrate that science works, that data is shared, that truth is pursued openly. Or they can stay silent, fuel speculation, and damage their credibility. I know which path I'd prefer.
This has been intense. We've heard from both sides. We've explored what's at stake. What's your gut feeling right now?
My gut? I think we're looking at an object that challenges our categories. Whether that means it's artificial or just a type of natural object we've never seen, I genuinely don't know. But I know the question is worth asking, the debate is worth having, and the answer, whatever it is, will change how we see the universe. In our final episode, Part 5, we're going to look forward. What happens when 3I reaches perihelion in January? What observations are planned? What would definitive proof of artificiality look like? And what would definitive proof of natural origin look like? We'll also talk about the long-term implications for space exploration, SETI, and humanity's future. Because whether 3I is a comet or a probe, it's already changed the conversation. We're asking questions now that we weren't asking a year ago.
And we'll address what happens if NASA never releases the data. What recourse does the public have? What can scientists do?
If you've made it this far, you're invested in this story, and so are we. Comment below, what do you think NASA should do? Release the data now, or wait until they have definitive conclusions?
And do you trust that they're handling this appropriately? Or do you think transparency should be the priority?
Hit subscribe for the final episode. This isn't over. In fact, the most important observations are still ahead of us.
Next time, the future. What comes next and what it means for all of us.
Stay engaged, stay thoughtful, and we'll see you for the conclusion.
We've covered the discovery, the anomalies, the hypotheses, and the debates. Now we look forward.
January 13th, 2026 is the moment of truth. Perihelion, when 3I gets as close to the sun as it ever will, and when we'll get our best, and possibly last, chance to understand what this thing really is.
This is the finale. Let's talk about the future.
January 13, 2026. Mark that date. On that day, 3I will reach perihelion, its closest approach to the sun, at about 0.39 astronomical units. For reference, that's inside Mercury's orbit. It's going to get very hot, very bright, and very active.
What happens at that point?
If it's a natural comet, we expect maximum outgassing. The nucleus will heat up to several hundred degrees Celsius. Volatile materials, water ice, CO2 ice, whatever's in there, will sublimate rapidly. The coma should expand dramatically. The tail should become spectacular, visible even to amateur astronomers from Earth. We'll have every major observatory on the planet pointed at it. The European Southern Observatory's Very Large Telescope in Chile, the Keck Observatory in Hawaii, the Subaru Telescope. Ground-based observatories across 6 continents, all coordinating observations across multiple wavelengths: optical, infrared, radio, ultraviolet.
And space-based telescopes.
That's where it gets exciting. James Webb Space Telescope has submitted observation proposals. If approved, and there's strong pressure to approve them, Webb will observe 3I LAS in mid-infrared, looking for thermal emissions, chemical signatures, and structural features invisible from the ground. Hubble will continue monitoring in optical and UV wavelengths. The Chandra X-ray Observatory might look for X-ray emissions if the object shows any charged particle interactions with the solar wind. Even TES, the exoplanet hunter, could contribute by looking for brightness variations that might reveal rotation or surface features.
So basically, we're throwing everything we have at it.
Everything. This is a once-in-a-lifetime opportunity. Interstellar objects don't come around often, and when they do, they're gone. We have one shot to get this right. Let's talk about what definitive proof of natural origin would look like. What would convince even the skeptics that this is just a weird comet? First, predictable behavior. If 3I LAS follows standard comet physics from here on out, brightness increasing with solar proximity according to known models, outgassing rates matching the surface area and composition, orbit changing only in ways explained by those outgassing forces. That's strong evidence for natural origin. Second, composition consistency. If spectroscopic analysis shows that the weird chemistry, the CO2 dominance, the nickel ratio, can be explained by a plausible formation environment, that helps. Maybe we detect trace elements that confirm it came from a specific type of stellar system. Maybe we find isotope ratios that match known supernova enrichment patterns. Third, structural simplicity. If the highest resolution images from Webb or ground-based adaptive optics show an irregular, lumpy, clearly natural nucleus, no geometric patterns, no surface features that look engineered, that would tilt the scales toward natural.
But none of those things are definitive, right? A probe could be designed to look natural.
True, which is why proving natural origin is actually harder than proving artificial origin. You can't prove a negative, but you can build a preponderance of evidence. Now the flip side. What would definitively prove artificiality? Let's go from weakest to strongest evidence. Weak evidence, continued statistical anomalies. If the orbit keeps showing non-gravitational accelerations that don't match outgassing models, that's suggestive but not conclusive. If the chemistry remains inexplicable, same thing. Anomalies pile up, but they don't prove design. Moderate evidence, structured signals. If SETI detects narrowband radio emissions, or if we observe modulated optical flashes, or if there are infrared pulses that look like communication, that's harder to explain naturally. Pulsars emit regular signals, but they're broadband. A narrowband signal, especially one with structure or information content, screams artificial. Strong evidence, thermal anomalies. If Webb detects a heat source that's too strong for solar heating alone, suggesting an internal power source like a radioisotope thermoelectric generator or fusion reactor, that's very hard to explain naturally. Comets don't generate their own heat beyond minimal radioactive decay. Definitive evidence, geometric features. If we get high-resolution images showing surface structures that are clearly manufactured, panels, antennas, ports, anything with straight edges or regular patterns, game over. Game over.
Has anyone looked for that yet? Like, really looked?
The Mars Orbiter data we haven't seen yet should have that resolution. HiRISE, on Mars Reconnaissance Orbiter, can resolve features down to about 30 kilometers per pixel at the distance 3I LAS was during closest approach. That's not enough to see fine detail, but it's enough to see large-scale structures if they exist. That's why the silence is so loud. If HiRISE saw an irregular blob, they'd tell us. If they saw something geometric, they'd be paralyzed trying to figure out how to announce it.
Okay, hypothetical. Let's say on January 14th, NASA holds a press conference and says, "We've confirmed it. 3I LAS is artificial. It's a probe." What happens in the first 24 hours?
Chaos. But organized chaos, hopefully. Let me walk you through what should happen versus what might happen. What should happen? Coordinated international response. NASA, ESA, JAXA, Roscosmos, CNSA, all the major space agencies, one DIGNMP, should issue a joint statement. The UN Committee on the Peaceful Uses of Outer Space convenes an emergency session. Scientists worldwide are given access to all data immediately. The message should be clear. This is a scientific discovery, not a threat. The object is leaving the solar system. It showed no hostile intent. It's an opportunity to learn, not a reason to panic. Governments emphasize calm, rationality, and continued observation.
And what might actually happen?
Probably messier. If NASA announces a loan without international coordination, you get geopolitical tension immediately. China asks why they weren't consulted. Russia questions the data. European allies demand transparency. It becomes political before it becomes scientific. Financial markets react, not rationally, just react. Space-related stocks might surge on speculation about increased funding. Defense contractors might spike on fears of militarization. Or everything tanks because uncertainty causes investors to flee to safe assets. Social media explodes. Misinformation spreads faster than facts. Conspiracy theories about government cover-ups, alien invasions, religious apocalypse. All of that surfaces instantly. Legitimate scientists spend days trying to correct false narratives instead of analyzing data. And then there's the religious and philosophical response. Some see it as confirmation of ancient astronaut theories. Some see it as divine revelation. Some see it as existential threat. The public discourse fractures along existing ideological lines.
So basically, it depends on how well the announcement is managed.
Entirely. The 1969 moon landing was managed brilliantly. Clear communication, international cooperation, sense of shared human achievement. That's the model. But we're in a different media environment now. Information moves faster, trust in institutions is lower, and polarization is higher. It'll be a test of whether we can handle paradigm-shifting news like adults. Let's assume we get through the initial shock. What does confirmation of extraterrestrial technology do to science long-term? First, SETI gets revolutionized. For 60 years, SETI has been searching for radio signals with limited funding and mixed support. If we confirm that probes are out there, the search paradigm shifts. We stop only listening and start looking for physical artifacts. There's already a movement called archaeological esoteric, searching for ancient alien technology in our solar system. Right now, it's a fringe idea. After 3I ALAS confirmation, it becomes mainstream. We start seriously surveying the asteroid belt, the moon, Mars, looking for other probes or remnants of previous visits.
You think there could be more?
If the fleet hypothesis is correct, yes, and they might not all be in motion. Some could be parked in stable orbits, Lagrange points, high orbits around planets. We've barely cataloged everything in our solar system. There could be inactive probes from ancient missions we just never noticed because we weren't looking. Second, astrobiology gets a massive boost. The question shifts from, is there life out there, to how common is intelligent technological life? That's a much more specific question with much bigger implications. Funding for exoplanet characterization, atmospheric spectroscopy, biosignature detection, all of that increases. Third, space exploration becomes urgent. If we know other civilizations have explored the galaxy, the idea that humanity should too becomes compelling. Mars colonization, asteroid mining, lunar bases, these stop being science fiction aspirations and start being strategic imperatives. We want a seat at the table, cosmically speaking. But there's a darker possibility we need to address. What if we confirm it's artificial, but then the probe does something unexpected?
Like what?
Like change course, like activate, like head toward Earth instead of leaving the system. I want to be clear, there's no evidence this will happen, but responsible planning requires considering possibilities, even unlikely ones. Scenario 1. The probe alters trajectory after perihelion. Maybe it uses the sun for a gravity assist, or maybe it activates propulsion. If it heads toward Earth, we have months to years to prepare, depending on its speed. That's not an immediate threat, but it's a strategic challenge. What do? Track it continuously. Try to communicate, send signals across all frequencies. Prepare intercept missions, not weapons, but rendezvous spacecraft to make closer observations. Establish international protocols for response. Scenario 2, the probe releases smaller objects. Maybe it's a carrier vessel that deploys subprobes as it passes through the solar system. We suddenly have multiple unknowns to track. That's not necessarily hostile. Scientific missions do this all the time, but it complicates monitoring. Scenario 3, the probe transmits to its origin. We detect a powerful directed signal beaming back toward the WOW signal region. That tells us two things. The origin civilization might still exist, and they now have updated information about our solar system, including the fact that we're here and we've detected their probe.
Is that bad?
Not necessarily, but it means we've been noticed. What happens next is out of our hands. Maybe they're thrilled. First contact. Maybe they're indifferent. We're just another data point. Maybe they're alarmed. An unpredictable species has achieved technology. We don't know their ethics, their intentions, or their capabilities. The Fermi paradox asks, where is everybody? One answer is, they're quiet on purpose. They don't announce themselves because broadcasting your presence across interstellar space might be dangerous. If that's true, and 3i just told its creators we're here, we may have been volunteered for contact we're not ready for.
That's terrifying.
Or it's wonderful. It depends on who they are and what they want. And we won't know until we know. We should talk about planetary defense, because this is where science meets security. Currently, Earth has infrastructure for detecting and tracking near-Earth asteroids that might pose impact threats. NASA's Planetary Defense Coordination Office monitors thousands of objects. But that system is designed for natural objects with predictable orbits. If we confirm artificial interstellar probes exist, the threat model changes. We're no longer just worried about dumb rocks. We have to consider objects that can maneuver, that might have purposes we don't understand, that could potentially be hostile.
You're talking about weaponizing space.
I'm talking about being prudent. The Outer Space Treaty of 1967 prohibits weapons of mass destruction in space. That should remain in force. But having the capability to intercept and study an unknown object, or, in a worst-case scenario, deflect it, is not the same as weaponization. We should develop rendezvous technology, spacecraft that can quickly launch and match trajectory with an interstellar object. Not to destroy it, but to observe it up close, understand it, and if necessary, communicate with it or alter its path. This is dual-use technology. It protects us from natural asteroid threats and gives us options for dealing with artificial unknowns. Every major spacefaring nation should invest in this capability.
Let's zoom out. Big picture. If we confirm we're not alone, how does that change humanity's self-conception?
That's the deepest question. For all of human history, we've been the only intelligence we know of. Every philosophy, every religion, every political system has been built on that assumption. Confirmation of extraterrestrial intelligence, even ancient, possibly extinct intelligence, shatters that. We become part of a cosmic community. Maybe a community of species that never meet, separated by vast distances in time, but a community nonetheless. Some people find that comforting. We're not alone. The universe is full of life and thought. Others find it threatening. Our specialness is diminished. We're not the center of creation. But here's what I think it really does. It gives us perspective. The Carl Sagan pale blue dot moment amplified. All our conflicts, our borders, our differences, they're provincial, petty. We're one species on one planet in a galaxy that might be teeming with others who've been through all of this before. Maybe that humbles us. Maybe it inspires us. Maybe it terrifies us. Probably all three. But it changes the conversation about what it means to be human.
You said earlier that 3i Atlas has already changed the conversation, even before we have definitive answers. What did you mean?
I meant that we're asking questions now that we weren't asking 2 years ago. Before Oumuamua in 2017, the idea that we might detect an interstellar probe was abstract, science fiction. After Oumuamua, it became plausible. We're now seriously discussing protocols for contact. Not if we ever make contact someday, but what do we do when 3i transmits to its origin in 3 months? That's a different conversation. We're debating ethics. Do we try to intercept and study the probe up close, potentially interfering with its mission? Do we attempt communication, risking revealing more about ourselves than we intended? Do we just watch and gather data passively? We're reconsidering our place in the cosmos. Are we a young civilization taking its first steps? Or are we late to a party that's been going on for billions of years? Are we being watched, evaluated, judged, or are we shouting into a void with only silent machines drifting by as evidence that someone else was once out there? These aren't academic questions anymore. They're practical, immediate, and consequential. That's what 3ILAS has done. It's made the abstract real.
So, regardless of what we find out in January, we've already changed.
We have. And there's no going back. Once you've seriously considered that an object in your solar system might be artificial, you can't unsee that possibility. Every new interstellar object we detect from now on will be scrutinized not just as a curiosity, but as a potential messenger.
Let's address the elephant in the room one more time. What if NASA just never releases the Mars orbiter data? What can anyone do about that?
That's a legitimate question. Legally, NASA is a civilian agency funded by taxpayers. In principle, their data should be public. But in practice, there are exceptions for national security, ongoing analysis, and data quality concerns. If the data truly shows something that implicates national security and potential extraterrestrial technology, might qualify, there are legal mechanisms to classify it. The president could invoke executive authority.
Could Congress intervene?
They could try. Congressional oversight committees can demand briefings, classified or otherwise. But if the executive branch decides this is a matter of national security, Congress's power is limited. They could make noise, hold hearings, threaten funding cuts. But they can't force release if the administration says no. The real pressure would come from international partners. ESA has their own Mars orbiters. ExoMars has data. If NASA clams up, but ESA decides to release their data, that forces NASA's hand. You can't keep secrets when your partners are talking.
So the international community is the check on any one nation's secrecy.
Exactly. And that's why international cooperation in space is so important. It prevents any single government from monopolizing information about discoveries that belong to all humanity. Let me take you out 100 years. It's 2125. What does the world look like if 3ILAS was confirmed artificial versus natural? Scenario 1, natural. We learned it was a weird but ultimately explainable interstellar comet. Science advanced. We updated our models of planetary formation and interstellar chemistry. Life went on. We kept searching for extraterrestrial intelligence, still uncertain if anyone's out there. Scenario 2, artificial but silent. We confirmed it was a probe, but it left without further interaction. That knowledge transformed us. We became obsessed with finding others, building our own interstellar probes, sending messages. By 225, we've launched humanity's first true interstellar mission, not just a Voyager-style flyby, but a probe designed to reach another star and search for artifacts like 3ILAS. Scenario 3, artificial and responsive. The probe transmitted to its origin. Decades later, we detected a response, a signal from the direction of the WOW source. By 225, we're in a long-distance dialogue, exchanging information at the speed of light. It takes decades for each exchange, but we're learning. About them, about the galaxy, about other civilizations. Scenario 4, artificial and active. The probe changed course, approached Earth, and initiated direct contact. By 225, we're part of a galactic community. Or we're under quarantine, observed but not yet trusted. Or we've been uplifted, given technology and knowledge we wouldn't have achieved for centuries.
Which scenario do you think is most likely?
I think scenario 2 is most likely if it's artificial. Probes from long dead or distant civilizations, silent, just collecting data. We find evidence we're not alone, but no one's home to talk to. We're left with questions and a universe that's suddenly more mysterious and more meaningful.
We're at the end. 5 episodes, thousands of words. We've covered the discovery, the science, the debates, the implications. What's your final takeaway?
My final takeaway is this. 3ILAS, whatever it is, has reminded us that the universe is full of surprises. We think we know the rules, and then something comes along that doesn't fit. That's not a failure of science. That's science working exactly as it should. Confronting the unknown, updating our models, asking better questions. Whether 3I Atlas is a comet or a probe, it's changed how we look at interstellar visitors. It's forced us to take seriously the possibility that we might find evidence of other intelligences, not through radio signals, but through artifacts drifting through space. And maybe most importantly, it's united people across disciplines, nations, and worldviews in asking the same question, are we alone? That question transcends politics, religion, culture. It's fundamentally human. And pursuing the answer makes us better.
What do you hope happens in January?
I hope we get clear data. I hope NASA releases it transparently. I hope the global scientific community comes together to analyze it openly. And I hope that whatever we find, natural or artificial, mundane or extraordinary, we handle it with the maturity and wisdom our species is capable of. Because this could be a hinge point in human history. The moment we stop being alone in our understanding of the cosmos, or the moment we learn nature is even stranger than we imagined. Either way, it's a privilege to be alive to witness it.
January 13, 2020. Perihelion will be watching.
And whatever Three Eyelass reveals, we'll be here to break it down. This series might be ending, but the story is just beginning.
If you've made it through all 5 parts, thank you. Seriously. This has been a journey and you've been part of it.
Comment below. What do you think we'll find in January? Natural comet, ancient probe, or something we can't even imagine yet? And what question do you still have that we didn't answer?
Subscribe if you haven't, because when the perihelion data drops, we'll be back with a special episode breaking it all down. This conversation isn't over.
Share this series with someone who loves space, who asks big questions, who wonders what's out there. These are the conversations humanity needs to be having.
From both of us, thank you for watching, for thinking, for caring about this. The universe is vast and strange and full of mysteries, and we get to explore it together.
Stay curious, stay critical, stay human, and keep looking up.
This is Doral,
And Mark.
until next time.